Hello everyone, in today's video we're going to trace the insertion sort algorithm, go over what it is, how it works, and the goal of this video is to try and help you guys understand how the algorithm works and maybe apply it yourself if you ever have to sort something, sort a set of items. So the first part of insertion sort is iterate, go through list item at a time. Should probably do a smaller stroke width, but yeah, go through the list one item at a time. So essentially, okay, and treat the list as two separate lists. One sorted, one unsorted. So essentially we're going to split this list of items up into two separate lists conceptually. Abstractly, we're just going to treat this first element right here as a sorted list. And what we're going to do is we're going to continuously insert each new element into that sorted list. And we'll find that it's actually much more efficient to insert an item into a sorted list than to try and sort a whole list. So let's just do that right now. So going through each of these steps. So I'm just going to draw like a line here to separate the sorted and the unsorted. This will slowly increase as we go through the list. So each time we go through the list, it's going to be one pass. I'm just going to state that right now. So this is the first pass. So what we're going to do is we're going to insert this item right here. Insert this item into the sorted list. So, and the way we can do that is we would just take the element and compare it with each item. We would check if it's greater. So since 5 is greater than 1, we're not going to swap it. We're just going to leave it where it is. And we're going to rewrite the whole entire list. So now our sorted part is right here. A bit. Okay. So now our current item, or pointer so to speak, is right here at 6. We don't start at 1 as our pointer because we already know it's sorted, so, and we don't have anything to compare it with anyway. So we're starting at 6 now. And so that was our first pass. So we're just going to check. We're going to iterate through the whole entire sorted list part. So 6 greater than 1, yes. Now we're going to swap them. So I'm just doing this in place. Actually, let's not do that. Let's write it out again. So 6, 5, 1, 7, 2. So during a pass, you're going to make several different swaps, but this is the first swap. So now I'm going to use 1 to compare. Sorry, I messed this up. We didn't want to swap there, right? Because 6 is greater than 1. So now we check with 5. So 6 greater than 5. Sorry, is it less than? If it's less, then we swap. But since 6 is greater than 5, we don't do anything, so that was the entire pass done. No swaps that time either. So now our sorted array is growing in size, our sorted list, so that was the second pass. So now we're checking 7. Say, hey, is 7 less than 1? No, so we're not going to swap. 7 less than 5? No. Swap. 7 less than 6? Nope. So then we just leave that where it is because it's in the correct spot. Now our sorted list bigger than our actual numbers we're inserting. So now we look at 2 and 3. We're looking at 2 first, so we're pointing at 2. And that was our third pass. So now we're looking at 2, and we are going to make some swaps here, but not yet. So is 2 less than 1? No. So we don't swap. Is 2 less than 5? Yes. So we're going to swap 2 and 5. We're not done yet, but they're... Yeah, okay. So now they're swapped. And we were right here, so now we're looking at 6. Is 5 less than 6? It is, so we're going to swap. Now we do it again. 6 less than 7? It is, so we're going to swap. Now we're done. That was our fourth pass, and now our sorted sublist, so to speak, is 5 elements long, 5 numbers. And this is our final pass. So 5. So is 3 less than 1? No. Is 3 less than 2? No. Is 3 less than 5? Yes. So we're going to swap. Write out the other numbers. I'm going to keep it. Right. So we swapped 3 and 5, and now we're looking at 6. Is 5 less than 6? It is. So now we're going to swap. And then finally, is 6 less than 7? It is, so we just swap these two. That is our final pass, and our list of numbers is now sorted. So yeah, if we want to actually evaluate how efficient this algorithm is, you can see how many passes we did. I didn't count how many comparisons we did, but it's going to be roughly the same as the amount of passes. So, if not more. And we'll find on average, this algorithm is going to make roughly the length of the original array of numbers, the length squared comparisons. So as this grows, if this grows to like exponentially, to say like 1,000,000 numbers, then you can see how this is going to be a problem. So we're going to make 1,000,000 squared comparisons. That's a lot. And there's other much more efficient algorithms that are like log n, some log n algorithms out there. And that's much, I thought it'd be much less comparisons, of course. So yeah, hopefully that makes sense. Hopefully you understand the algorithm. Basically splitting it up into a sorted section, and then you're inserting each new element you go through in the list into that subarray. I keep using these terms interchangeably, but in programming they mean different things. So yeah, that's all that I wanted to share. Hopefully it made sense. If you have any questions, make sure to leave a comment down below and like and subscribe. So yeah, thanks for watching.